Okay. Anything? Yes.
So, sorry, there's something that was bothering me earlier, because you said something about, like something not being two functions, but being one function.
Something not being.
Two functions, but actually just being one function. Yeah, I don't, I'd like say this question, there's two functions, right?
Sure.
Then after multiple using the product at first.
Yeah, this function, this is one function, is made up of the product of two functions. Yes. Does everyone agree? I've written one function up here, yes? That one function, what's that?
Sorry, I just like calling it one function. I mean, technically that's true, but really, like the derivative is we're looking for the derivative, so we need to like use the product rule.
Of course, because what goes into this one function?
Yeah, you keep saying that. It's awkward. Sorry. But yeah, basically
Right.
you
Help me out, dude. What's this function made of? What's the two product? You're right, it's a product rule, correct? What are the two functions you see?
I see e power x.
Good, e to the x.
Yeah, and then I see x squared plus 5x.
Kick ass. Now, when I multiply those together, what does it create?
It creates one function. Yeah.
Good, there you go.
Yeah,
That's all I'm saying.
Yeah. No, I thought you were saying this is one function. No,
No,
the
it
derivative
totally is. All right.
I mean, technically.
How do I know this is one function? Because says f of x equals this one function. No.
It's just like.
You guys with me?
Sorry.
So the more complicated a function that I give you, the more complicated the derivative could be, right? Especially if I can't simplify it. You with me? So it's kind of an important point to realize. This is one function, but when I look at it, this is the product of two functions in it, yes? This one function has another function times this function, yes?
Should we just call them sub-functions for simplicity's sake?
You can call it whatever you want to.
All right.
You can call them Jack and Jill, yeah. Okay. All right, I'm not sure what the disconnect is there. I don't know. Okay. So really, watch this. This would be what rule primarily, like you just told me? Product rule. What would this be? This is made with the exact same functions I made this out of. This one, I took the two functions and I multiplied them together to make this one function. This one, I took the two functions and I did what?
I don't know the rule, but basically just, well, since it's e to the power, you would just, well, since it's actually log of the exponential value, you just multiply it. Because it's
Okay, real quick.
e, which,
This one's got this function in it, and it's got this function in it. Yes?
yeah,
This one also has this function in it and this function in it. But how did I put G together? I took this function and I did what with it?
and you put it,
I shoved it in there. So that means what rule will I use for this one function? Chain rule. Yeah.
yeah, I got that.
Okay. And then the best thing in the world is if I decide instead to take the two functions and add them together. That's what you hope I would do, right?
Yeah, that's
Yeah.
what I said about that.
Because then all three of these have the same two functions in them. All three of them do. This one multiplies them, so it needs a product rule. This one shoves one into the other one and needs a chain rule. This one just adds them together, and then I could just take the derivative of each piece.
Right, yeah. Yeah, I think that the problem with that would, since, like, when you do chain rule or product rule, it, from what I recall, like, you tend, like, not there's some similarities with like, your,
Well, all right, the overriding theme to me that I told you guys about is the three big rules we've discussed. We got power rule, which is not since there. We got product rule, quotient rule, chain rule. The one big tie together thread of all three is all the functions involved get their own term. They have a derivative, correct? That was the big thing. You don't do both parts. So I'm going to take the derivative of this. I'm not going to take the derivative of both of these at the same time, right? Chain rule, I'm not going to take the derivative of both of these at the same time. Quotient rule, I'm not going to take the derivative of the top over the derivative of the bottom. That's never how it's going to work. Yeah? I don't know, do you guys understand what I mean when I say each part gets its own term? Product rule, f prime g plus fg prime. F got a term, and then g got a term. Right? like a swing. I can't, both kids put them in there, that's not gonna be good. One kid gets a turn, and then the next kid gets on there, right? Chain rule, the outside gets a turn, then the inside gets a turn, right? Okay. Anything else from just generally or homework stuff, or how's homework going? How you guys doing? I think I gotta get in there and put some more in WebAssign. I think I stopped at 3.6.
3.5.
Did I stop at 3.5?
Yeah.
Ooh, I suck really bad. Listen, my WebAssign people, you know how I feel about online homework. I've said it before. I don't think about it. I'm really sorry. You're gonna have to remind me. It was how do I say this? I don't care if you think I'm an asshole. It was a nice thing I did. It was a nice thing I did. I didn't want to, and I thought, no, I'll make it an option. So if you could just do me a favor and just remind me. If I forget to put more homework in there, just say, hey, dude. Don't just sit back and go, oh, sweet, I got less to do. No, it's all due by the day of the test. You with me?
Yeah, I was a little confused because I remember you mentioning like 3.9 or something, and I was wondering why that's on the website.
Yeah, because I don't think about it. Yes?
Can we please go over the question from 3.2 homework?
Yeah.
It's number 25.
Okay. Oh yeah, okay. So real quick, this is what sucks about, and again, I'm about to say something that I lived myself as a student. Because I told you guys all about the sob story about I had all these jobs and blah, blah, blah. And when you do section 3.2 homework, you cannot use a process you learned in 3.3. Does that make sense? So if you do 3.1 homework and we've already lectured up through 3.4, great. You better only use stuff you knew by the time you do 3.1. Does that make sense? Does that make sense? Okay. So you gotta be really careful. If you're like I was as a student and I only had weekends to do homework, I learn a lot of shit over the week, and then on the weekend, I gotta put myself in the mindset of the section I'm in. Because the teacher ain't gonna like it when I use something from a later section. Does everybody understand what I'm saying?
Theoretically, yes, but it seems. Never mind.
Okay. So on one level, I understand, because you're like, if I know it, why can't I use it? Because since the problem is in that section, it's trying to make a point. So if you use a later rule, you're missing a point it's trying to make. So for example, real quick, in I think 3.2 is where you learn product. I'll come back to this. I know you had a specific question about this, but like in section 3.1, where's that problem? Here. If you see this problem on a test or something now, on the next test, can you use quotient rule for it? Yes. Can you do that in section 3.1? No. Because what do you think the point it's trying to make is? What do you do then? You don't know quotient rule and they gave you this problem. Is that mean? Is that evil?
I mean, it kind of seems like, I shouldn't have been it for a reason, but like, if the point is just to tell us that we need to learn quotient rule.
No. This is a problem in the homework. You have to do it.
You just get
Yeah.
rid of both bottom.
No, hell no. Of course not. Of course not. All right, so.
Like,
What did I tell you guys? If I give you a function and I ask you to do calculus to it, what do you try to do first? This is the big thing. Simplify. Holy shit, if I can simplify it, hell yeah. So what's being divided by w to the 1/2? What's being divided by w to the 1/2?
Everything.
That's being divided by w to the 1/2, that's being divided, and that's being divided. So separate them, and then you got 3 parts, and then it's power rule, screw quotient rule. Later, you could choose to use quotient rule on a test when everything's mixed together, but this section is trying to show you, wait a minute, you might know quotient rule, but don't do that shit here. You're in 3.1. You shouldn't need to, so then you should go, oh, what else could I do? Yes, maybe? Now I understand, trust me. On one level, you're like, if I know it, I should be able to do it. But then you're missing stuff. There's a reason they put those kind of problems in there now. Is to remind you, hey, you can make this a lot easier if you just break it up. And if you did 3-1 before we talked about 3-2, and I'm not saying you should have, I totally understand about doing homework whenever you can. But if you did, you wouldn't even know quotient rule yet. Then you'd be forced to think, okay, what else can I do, right? Is that all right?
Yeah, I mean, the one thing I'm slightly confused about that question. So I kind of understand that essentially you'd be treating, like you basically be simply simplifies because it's like the square root, you're dividing by the square root of w. So you'd essentially be like, and obviously the square root of w is effectively w to like the power of 1/2, right? So then you would then end up with like, I mean, it would be actually like what would that look like? How would you simplify?
Okay, okay.
Because it would be like
Unfreeze this poor book here. Let's see. How can I do this? Let me write it down. Let me get my eyeballs. Okay. So here's the problem. I'm not sure if this is a homework problem or not. I don't think it is, but it's just the first one I saw that was the kind I wanted, right? So there's the problem. And they called it P of W because they're weird. Now, if you did quotient rule, there's nothing wrong with it. I would just want you to reduce it as much as you could. And you could do a lot more reducing. So either you reduce it first or you reduce it last. I'd much rather reduce it first because then I don't have to use a funky ass rule like quotient rule. So, let me say this again. What is being divided by W to the 1/2? Yeah, so be specific. 2W squared is being divided, right? W is being divided. 4 is being divided. Isn't that just freaking like denominators in reverse? If they have the same denominator, I can shove them together, so I should be able to rip them back apart. It's a great thing about mathematics, it goes both ways. Be jealous. How do I simplify this? No. What do you do with powers when you divide? Subtract 2 minus 1/2. 4/2 minus 1/2. 3/2. Yeah, I thought you said negative. And then here, a whole W divided by half a W. It's half a W. And then here, how would I rewrite this? Yes, you want to move it up so then it's in the form of variable to a number. If it's in the form of variable to a number, easy. One of the best derivative rules ever. Right now you take a derivative, you got a bunch of W to the n, W to the n, W to the n, right? Much, even once I learn quotient rule, I don't want to use quotient rule on that dumb thing. No, hell no, that would be disgusting. I'd much rather do this.
yeah, this doesn't nicer.
Yes, that's the point. Okay, sorry. Okay, I didn't finish it, right? You have to take the derivative now, but now the derivative's easy. Is that all right? Okay. What's different about this problem? If they gave you this problem instead, what do you got, Jeff? I don't know, Jeff. Oh, you're right. Why can't I do the same thing here? I technically could, but it wouldn't take me anywhere. Well, there's a funny thing about the way I set that up, actually, but it's okay. Why couldn't I just directly do the same thing I just did? Because can I reduce x squared over x squared plus 2? There's no reason to break it up. If the bottom is one term, break that shit up. Because then you can reduce each piece. If the bottom is more than one term, quotient rule. Screw that shit.
Well, you want to do the quotient rule anyways, but you will do it like 3 times. If you break it.
I know, exactly. Yeah.
You just do it once.
Now, I don't know if anybody notices. I don't want to say this almost, but no, it wouldn't work that way. Okay, good. If I would have made that cube, there would have been something else you could have done, but I'm okay. Is that all right? That's a huge thing just to realize. If the bottom is one term, break that shit up. If the bottom is more than one term, oh well. Quotient rule. Yes. Okay. Anything else? Any general questions? Any specific? Yes.
If it is a squared function, how would we do that without g?
Oh, sure.
Would we just like separate them and then do?
Yeah, square. Yeah. Like.
It's kind of like question 20 and 21.
Yeah, there we go.
Yeah.
Yep, square. FOIL it. Write it twice. FOIL it out. It's not 14 squared plus 9. Dear God. Yes? Okay, two things. A plus b squared is not a squared plus b squared. The square root of a squared plus b squared is not a plus b. Yes?
Yeah.
Dear God. Right? Okay. This is huge in Calc 2. It's huge all the time. But in Calc 2, there's a bunch of problems that have this form in it. And if you do that, you're like, oh, this is easy. Why is the teacher making it so hard? I'm like, no, you're getting to the answer quick, but it's the wrong answer. So it's not good. You guys with me? Does everybody understand why this is not true? Both of these are not equal. Yes? Maybe? Okay. Okay. Anything else? Okay, so.
Number 25 from
Oh.
3.2, we never went over it.
I'm sorry. Oh, that's right. 2. 25. Oh, yeah, okay. So this one, bottom's got 2 terms. I can rewrite the top, of course, out of the stupid radical notation into the better function, fractional power. And then you just do quotient rule. 3.2 is where you learn product and quotient, if I remember correctly. So you just attack it with quotient rule. Did something specific go wrong?
I guess more time.
Oh yeah, how did that become a 1/3? It's just that times 3, so the power should stay the same. There's no t there. Here the t is there, so you add the powers. Here there is no t there, so when you distribute it, it should still be t to the negative 2/3. Yep, okay. Okay. Anything else? Okay. Now listen, I apologize. All right. So we're all in calculus. There's a certain level of ability at that to really be able to get the calculus concepts. At the same time, if you're having trouble on something that I'm like in class going, you have to know how to do this, come see me. In class, I don't have the most time in the world to review an entire algebraic concept. I don't, because I have the calculus to do, right? You guys with me? But if you just come see me, we can work out a plan. I've got stupid amounts of worksheets. I can sit down and explain the concept to you. That's insane. When you come to see me in office hours or whatever, we can talk about any math-related stuff, anything for whatever length of time you need. In class, I only have so much time to do like a review. I have a lot of calculus stuff to do. You guys with me? So I don't want to. I'm really sorry if I come off sometimes like, you gotta do it. But in this class, you have to know how to do this stuff. You have all kinds of ways to review that outside of class. In class, I'll do some review, whatever I can fit. You guys come? Okay. So I don't want you, I'm really sorry if I came off like that. I need to communicate to you that certain things you must know. And if you do not know them, I need you to understand how important it is for you to know them. Yes? And then you just hook up with whatever resources available. If you don't have any time, if you literally come here from work and then you go right back to work after class and then you sleep for 2 hours and then you have like 6 jobs. If something like that's happening, reach out to me. We'll figure something out. Yes? I've got videos that I can give you that you can watch or you can listen to as you go to sleep or whatever. We'll figure something out. Are you guys with me? Okay. All right. So today, what I want to focus on. So last time we did 3.6, we did 3.7. Grade's not in our stuff. So now, does anyone remember? I already told you guys what was coming. Does anyone remember what's coming? You're in a math class, so you know at some point we have to have word problems. So let's do this. We're going to ease into this. If I have a circle, what is the area? What do I need to know the area of the circle? Yeah, so if I have a circle and I tell you the radius, right, this is a little dude with a nose ring. If I tell you, or he's got like a straw in his mouth. So if I tell you the radius is r, of course, what's the area of that circle? That's insane. Now, what if this is a, what if this is, I can't remember if I told this to you already, I feel like it. What if I throw a rock into a pond, what kind of emanates from that? Ripples, right? And aren't they circular because they go out in all the directions, right? If it's a still pond, no wind, and I throw a rock in there, right? Something that for some reason, especially little boys like to do that. When I was a little boy, if I could throw a freaking rock into a lake, it just did something for me. I don't know. So then you watch the little circle go out. What's happening as the circle goes out? What's changing? Expanding. So the radius is getting bigger, and of course that means the area is getting bigger. Correct? The rate at which the area gets bigger depends on the rate at which the radius gets bigger. Correct? What does this function set up? It sets up a relationship between what? What's this function set up? A relationship between area and radius. So do you agree with me that this is a relationship between A and R? This is relating those two variables. Those variables are related. R changes, A changes. If I want A to change, I gotta make R change, yes? Okay, so this is neat. Now watch this. What if I told you, the radius, all right, let me just say this in English. The radius is changing at a rate of 2 millimeters per second. So I didn't just tell you the radius is something, I told you the radius is changing. What symbols could I use to describe that? I can't say r equals 2, correct? If I say r equals 2, I'm saying that the radius is 2. Is that what that says? What's that say? Say it. That's the radius. So what symbol would I use? What symbols would I use? Could be a prime or even better. So this is dr. Change in radius over the change in time. Can we stop for a minute? Is that all right? So you could use r prime. dr dt is better for a few reasons. It's more explanatory. You can kind of see the units kind of match up, yes? And you make certain that you know what am I taking the derivative with respect to? Time. Does time show up in this equation? No. But time is changing this, which is changing this. So time's in the background. You guys with me? Okay, maybe. Okay, so watch this. What if the radius is 3 millimeters? What's the area of that rippling circle?
9.
It'll be pi times 3 squared, so it'll be 9 pi millimeters squared, which is roughly what? Can somebody do that? Somebody have the calculator? It's roughly 28.3, I don't know. I'm making shit up now.
28.274.
I'm sorry, I'll retire. I was way off. Alright, is that part okay? That part you just eat that shit up. If I'm like the radius is 3, you're like, kick ass, thank you, Jeff. Plug that shit in, there's your number, dude. Alright. What if I wait 1 second? What happens? Is everybody with me so far? Nothing much has happened. We threw a rock into a pond, and for some reason, we're going to sit down on the grass and think about calculus. Right? Threw a rock in a pond, little dude exists now. Little rippling circle dude. We notice this is happening somehow. We're just amazing like that. At a moment when it's 3 millimeters, the area of the circle is 28.27 millimeters squared roughly. Yes? What if I let 1 second go by? What changes?
Radius.
Yeah, what's the radius now?
5 millimeters.
Yeah, why is it 5 millimeters?
Because that's the rate of change for it.
Yeah, it changes by 2 millimeters every second, correct? Is everybody with me? Just to let you know, this is not gonna be what a problem looks like. I'm explaining the behind the scenes of a problem. We're doing a lot more right now than you would have to. Okay, is everybody with me so far? Nothing much has happened. The instant when it's 3 millimeters, the area is 28.27. I let 1 second go by. I know that the radius changes by 2 millimeters a second. So now you can figure out what's the new area.
25.
Yeah, pi times 5 squared, 25 pi, which is roughly, oh. 1/4, 3, 78 point, I don't know. Is it? I don't know. What is it?
78.50.
78.54? Okay. Oops, just millimeter squared, Jeff. You're doing a great job, Jeff. Millimeters squared, there we go. Let me stop for a minute, Again, this is not what a problem's gonna look like for you. Your problem is gonna be a lot more direct. I'm doing a lot more physical interpretation of what's going on. We haven't done much of anything. We know the radius changes 2 millimeters per second. We noticed at 3 millimeters, the area was that. We let a second go by. Now the area is that. Makes sense, because now the ripple's gone further out, yes? Okay. How much has the area changed? What is the gross change in the area? This symbol here means change in. Oops, become an E, become an N. This means Chang ein. This means the change in area. Not the instantaneous change, because this is the change in area over the course of a second, correct? So it's not the instantaneous change. How much did the area change by? How much did the area change by?
Like 30?
50.27, yes. So roughly 50.27 millimeters squared, yes? Is everybody with me? This is all concrete. Yeah? Okay. What if I wanted to know exactly how much is the area changing when the radius is 3 millimeters? Do you understand why the answer will probably be close to this, but won't be this? Because if I let the circle grow a little more, aren't all the slopes changing? If I let it, isn't the area a parabola or squared? So I'm here at 3 millimeters. If I let it move, the slope has changed now. Yes? So this is just like chapter 2. It's not going to be chapter 2. Do not freak out. I'm looking between 2 points, and I want to know the instantaneous rate of change of the area. Okay. So here's the kick-ass cool thing. This sounds like, holy shit, I'm going to do a table and stuff, and I'm going to pull my hair out again. It just grew back, Jeff, right? Here's what it's going to be. So everybody's got this stuff, yes? So let's look back here. Here's my relationship between A and R. I know dr dt. They told me this. What is it right now that I want to know? What did I just say I want to know? We have an estimate for it, but I want to know exactly what it is. dA dt, kick ass. You always put symbols for what they tell you, symbols for what they ask you. Yes? Why do you do that? Because what's important in algebra? You have an equation, you want to know where to put what number. You have to know what the freaking variables are. Yes? Now here's where everybody, okay, here we go. You ready? What am I allowing to go by? And I'm noticing changes. It's a weird way to say it, but what am I letting go by? What's time? Kick ass. So I'm going to take the derivative, of course, and in fact, if you didn't know this, it's in your face. What am I going to take the derivative with respect to? Time. Do you agree that area is a function of time here?
Yes.
Do you agree that radius is a function of time? But do you agree there's no t in this equation? Implicit. It's implicit differentiation. So I'll do this side. The derivative of a with respect to t is dA dt. I've done half of it. You're welcome. What's the derivative? What's pi, of course? It's just a number. It just comes to the right. Is that cool?
Yeah.
What's the derivative of r squared? The beginning of it is 2r. What am I taking the derivative with respect to? So times dRdt. Just like when you did the derivative of y in an implicit problem and it was dy dt, correct? Derivative of y squared would be 2y dy dt, or dy dx in that case. That is just chain rule. What's inside of the square? What's inside the square? A function of time, yes? Isn't r a function of time? You with me? So isn't there a function inside of another function? Isn't that chain rule? Derivative of the outside function, 2 comes down in front of it, times the derivative of the inside function. That's all that is. Now, this is a relationship between area and radius. This is a relationship between the change in area, the change in radius, and the radius. So that's why this section is called related rates. What did we just get a relationship between? The rate of change of radius and the rate of change of area. It's how the rates relate. So if I know how variables relate, I can take a derivative of both sides, and then I know how the rates of change relate. Why is that important? Every freaking STEM field there is, you very often mostly measure rates of change of things. And that has to be captured by that kind of relationship. Yes? Maybe. Now you look at it as a freaking algebra problem. It's just an algebra problem now. What do you know? Yeah, and I left one thing out. What was I wanted to know the instantaneous when the radius was 3 millimeters, yes? Yeah, when the radius is 3 millimeters, yes? So I know r, I know dr dt, and I'm trying to figure out what dA dt is. Do you see how that's just algebra? Just plugging shit in? Now you can chug shit out. So let's see, what do we get? What do we get? We get 12 pi, right? Which is roughly,
37.7.
sounds about right. Square millimeters per second. So that's the instantaneous rate of change at 3. Now real quick, let me see if I can add one more thing on here. Do you see how I have the radius at 3 and the radius at 5? If I do dA dt when the radius is 4, that'll be right between the two. That should be that's just like chapter 2. That's kind of, it should average those two out. Let's see. If the radius was 4, what do I get? Okay, 16 pi, which is roughly, I believe it's 49 point something maybe. Or maybe even 50 something. 50.3. And what did we actually get? So we got the area at 3 millimeters and the area at 5 millimeters, and we saw how much it changed by. If I get the instantaneous rate of change at 4, right in between the two, that should be a good estimate for that. And it is. I got 50.3 millimeters squared per second. Okay. So that's a nice concrete example of this kind of problem. I did a lot more than you have to do for most of these problems. Right? The bulk of the problem will be this: capture what they tell you, take the derivative, plug stuff in. Most of the problems are gonna go like that. So what's gonna make the problems more difficult is you have to come up with the formula in the first place. They're not all gonna be, here's the circle. Okay. Let's do one example that's a little more complicated, and then we'll take a break. I'll take one right out of the homework, you know that. Yeah, all right. Number 7, read through that real quick. I have no idea if I signed that for homework. If I did, you're welcome. I don't think I did. So too bad.
This is from 3.6.
3.9.
3.9.
Yes. Yes. 3.6 was like logarithmic and inverse derivatives. 3.7 was position function, velocity function. Yeah. You guys with me on this? What geometric formula are you going to need that you might not know? Yeah, the volume of a cylinder. Does anyone happen to know it? Yes. Yes. So the bottom of a cylinder is a circle, correct? You with me? So the area of that circle is pi r squared. The height of the cylinder is kind of like how many circles I have stacked up. So if I take h is the height, I have h pi r squares. So the volume is pi r squared times h. Any repeated shape, do you all agree that a rectangular solid is a repeated rectangle? Right? There's these things called records, and if you stack them all, they were squares, and some of them were rectangles. But all right, so if you stack a bunch of rectangles, length times width, and how many do I have of them? H. So that's why it's length times width times height, because I have H LWs stacked up. Yes. What's a cylinder? It's just a repeated circle. So if I know the area of the circle, I multiply by the height. That's the volume. That's how much it goes through. Now, real quick, do you have to remember that? No, I'll give it to you. But also, when you're doing your homework, I have no idea if you guys did what every math student should do, which is what the shit's in the front of the book, what the shit's in the back of the book. And what the shit is in the front of the book is some geometric shit. Look at that. Oh, look at that. Oh my God. Yeah. So if you didn't look, there is information up there. You guys with me? And if nobody noticed this business in the back, look at all this, look at all this, look at all this stuff. It's got calculus stuff, it's got freaking log stuff. I mean, hello. Reference pages in the back. Okay. Now I've got a used book and somebody ripped them out, too bad. All right. So let's do this. What did I just say? Number 7. So let's see. Cylindrical tank, radius of 5 meters, is being filled with water at a rate of 3 cubic meters per minute. How fast is the height of the water increasing? So can everybody attempt? Now look, drawing a cylinder is not that hard. Make like a circle, but from the edge. So you make like an ellipse, so you're looking at it from the edge, and then you just drop it down, and then you make another circle at the bottom, and you can even make it dotted and feel all nifty. I suck at drawing, so I know you guys probably could do a better job than me. Most of you. Now, let's label some stuff. We know the radius of this cylinder is 5 meters, yes? We don't know the height of the cylinder, but why does that not trouble me? What do I actually need to know the volume of? Not the whole cylinder. I don't care about that because that's not changing. What's changing over time? The height of the water. And doesn't the water, all right, here's how I say water. I say water like that. So right here I say water. That's how I say it, so just deal with it. At least I don't say I'm going to wash my car like my grandma did. Thank you. Okay. But I do say water, water. water, so sometimes I'll try to say water. High quality H2O. So you fill this thing with Kool-Aid. No, water. Can you draw in like just a random place the water level could be? So like you could do, again, you don't have to be all artistic. Yeah. So this, what do you think I'm gonna call that? Because do you know what that is? Do you know what the height is? We picked a random place, yes? So how high is that? H, kick ass. I was all right. Because we don't know. I'm just picking an arbitrary place the water could be, so I don't know where it is. What shape will that water be in? A cylinder, yeah. Just like hats, they take the shape of what you put them into, right? And the radius, of course, is 5. As the water level changes, does the radius change? Do you understand if it was a cone, it would? Okay, so the cone problems would be more interesting. Can somebody help me piece together a formula for the volume of the water? Do you remember the volume of a cylinder is pi r squared h? So what's the formula for the volume of the water? What's the radius? Doesn't it make sense that the volume of the water depends on how the water level, yes? If the water level is here, more volume of water. If it's there, less volume of water, right? This is a very simple example of you having to do something, because this is an established equation. We just had to plug one piece of information in it and we got our equation, yes? Okay. Do I have a relationship that relates the variables in the problem? Do you have an equation that relates the variables? No. Do I have an equation that relates the variables? Yeah, there it is. It relates H to V, yes? Is R a variable in this equation?
No, it's not.
Why not?
It has value.
Because it's freaking 5. I don't care what's going on, it's going to stay 5, right? We're assuming the cylinder doesn't blow up. That'd be a whole different problem. And then the R is definitely going to be different. Okay. Now, what do they tell me? What do they tell me? Number 7. 5 meters, we already put that down there. We already used it, correct? What do they tell me that I haven't used yet, that I haven't put down yet? Yeah, so how do I use, what's the symbols for this? Good. How do you know that? Because it's freaking meters cubed. So what is changing? Isn't that volume over time? dV dt. So you write down what they tell me. They tell me dV dt is, where'd it go? 3, it's being filled with water. Do you understand if there's a leak and water was leaking out, I would make that negative. Does that make sense? Maybe, Jeff, we're not going to tell you. Okay, so this is per minute. And what do they ask me for? What's the question want to know? dH dt. If you just take a minute, symbols for what they tell you, symbols for what they ask you. What do I do with this now? The river. I'll do this side. What's the derivative of this side? 25 pi dH dt. Yes. Now it's algebra, right? Now it's algebra. What do I put here? 3. And now I can solve for the thing I'm trying to solve for. dH dt, right? How do I solve for dH dt? Divide by 25 pi. And then whatever the hell that is, it's going to roughly be 0.039 What is it?
0.0338.
3.8? I suck. 3.8 what?
19.
Damn it! I'll retire. I'm sorry, guys. What's the units on this? Units should be one of the easiest damn things on problems like this. What's H in terms of?
Meters.
And what's time in terms of?
Minutes.
Meters per minute. So you cannot, if you just allow the problem to tell you the answer for units, you can't go wrong. Meters per minute. Done. All right, let's take a break. We'll do a more complicated problem and you guys come back. By the way, we're not gonna, I have to make an executive decision. We're only gonna get through 3.9. So 3.10 will be on the next test. 3.11, I'm gonna make extra credit. I will talk a little bit about it, but 3.11 is officially extra credit. Some of my colleagues don't even make it a thing, but I need you to know it exists, the stuff in 3.11. Is everybody with me? Homework through 3.9 is what you will be responsible for. When is the next test, by the way? Yeah, so I have the practice test today. So let's take a break and then come back at like, if you guys come back at 2:25, I'll let us out a little early. Okay?
For those type of problems, would it be okay if I would like be trying instead of TV? Or do you wanna see the picture?
I need you to get used to doing that. We're at a point in the class where we have to start using that more often. I don't know if you're gonna take any more calculus assistance, but that is one thing from calculus we've gotta do. Because if you do take more calculus assistance, that thing becomes much more important. Yeah, right now the prime is
Then
fine.
you start separating them as well.
Yes, one of the things when we get to pretend, I want everybody to be really used to this, because then we're gonna start doing stuff like dy equals 3x dx. Yeah.
Meter squared was meter.
Creating problems, I already did that. Let me give you this worksheet here. Need you, okay.
Oh, I thought it was the whole page. I was like, oh.
So, if you could, we're going
Maya, make sure I gave you one of these. Did I not give you? Oh. You should have a practice test and a related race.
Like I said, she has a name.
Oh.
was it test again from point 1 to point 2?
Yeah, 3.1 to 3.9.
3.9.
Okay. I can make it 10. So, my original plan was to let you guys work in groups, but just in the interest of time. Okay. Can you guys, all right, so a major problem students have, understandably, you don't really get a lot of practice with word problems anymore. As much as you guys hate them, you actually do a lot less of them than we used to, which is one reason why you hate them. Because we don't do them. It's kind of like driving in snow if you never drive in snow. Number one, can you draw that picture? You draw a picture representing what's happening. You don't have to draw a perfectly detailed airplane. You don't have to draw you looking up at the airplane, right? And do you understand there's two kind of time frames? it's directly overhead, and then I let it go for a little bit. Yes? Oh, and before I forget, all right, well, just draw the picture. Don't put any, you don't have to put any variables or words or whatever. So here I am, I'm this little dot. I've condensed myself into a center of mass. And the plane is here, and this distance is 3 miles. So, and you can even make a little plane. Whee! You don't have to, but there's a little plane, yes? A little plane up there, look at it. Look at it. It's only got wings, it's got no engines. The 3 mile altitude remains the same, correct? So for all my flat earthers, it does have to adjust a little bit for the curvature of the earth. Sorry. I'm gonna let it go for a little bit. 10 minutes at the moment, I don't give a shit how long. I'm just drawing the picture. I don't have to know any specifics. Let it go for a little bit. Where is it at now? Did I say a certain direction? I can't remember. Thank God, no. So now it's like here, yes? Maybe? Okay. So now if I look at it, I'm going to look here. I'm going to see it there. What shape have I made? Triangle. Now, is there a phrase in this problem that isn't familiar?
Oh, I just realized something a bit odd actually.
What's that?
Well, it says 44 miles per hour, but it asks if I between angle change in minutes.
Kick ass. So I'm going to worry about the units here in a bit. But that is something you definitely want to look out for, is do the units match. So you got to look out for problems where they say yards and over here they say feet. You're like, no, I got you. So we're going to have to worry about the units here in a bit. Is there a phrase in the problem that you've never heard before, or you're not sure about? There has to be. What's the angle all about? What's theta represent? Angle of elevation. What is that? Thank you. Okay, so when I say, is there something in there that doesn't sound familiar, like the freaking angle of elevation? What the shit is that? Maybe don't say exactly that, but you could say exactly that. I'll be fine with it. You ready? It's always from the perspective of the observer. If I look straight out, that's 0 degrees. 0 degrees. If I look up, I've gone through an angle of elevation. If I was in the plane looking down, I've gone through an angle of depression. Right? You with me? Sounds like I need assist, but I'm okay. It's just the angle of depression. If I look down from where I am, if I look up, the angle of elevation is related to the horizontal. So where is the angle of elevation in this picture? Is it in the triangle? No. So if I look straight out on the ground, I'm going to look this way. So of course my angle of elevation is there. So where is it in the triangle? Does anyone know? A little bit of geometry. A little bit of geometry. If the plane is maintaining a constant altitude, that means its path and the ground are parallel. I got a transversal. Where is theta in the triangle? Alternate interior, yes? What do these two have to be? They had to be 90, yes. And then that is 90, so therefore that's got to be theta. Okay. So now I got this contained triangle. Okay. And we've got variables. This problem told you what variable to use. Most problems won't. You have to pick your own variance. Now that I've got variables, I can start to write what they tell me. What do they tell me? Anything? Or what do they ask me, actually? Yeah, they tell me the velocity. Okay, so what variable am I still missing? I'm still missing something. What other aspect of this triangle is changing over time besides theta?
You know what the side is.
What's changing over time? What physically is moving?
The plane.
So isn't this side changing over time?
Yes, that is.
Can somebody give me a variable for it?
Distance.
You want to use, let's not use D, because then you get these DD and you sound like you're talking about Dexter's Lab. Let's call it X, yeah? Because it's in the X direction. Why not? So what variables do you need? You need to call everything that's changing over time needs to get a variable, because at any given time it's a different value, correct? So why did I put a 3 there instead of a variable there? Because it's freaking constant. So make sure you don't put a number somewhere that's changing over time. I know that's 3. I don't know what this shit is. Okay, stop for a minute. Can somebody tell me a relationship between... Oh, by the way, what did they ask me to find in symbols? Yeah, how quickly is the angle changing? What's the symbols for that?
D theta, dt.
Yes. What did they tell me? What rate of change do they tell me? And what symbols do I use? What's the only other variable in my picture? Yes, so what's the only other variable in my picture? What's the only other variable in my picture? X. Do I know how much that's changing over time? Yes, I do. I know exactly how much it's changing over time. Yeah, 300 miles an hour. Yeah. So what's the symbols? dx/dt is 300 miles per hour. Okay. This 10 minutes is what I call the snapshot information. If I see the plane go overhead and I wait like a minute, can't I snapshot that instant and the plane is a definitive distance forward? I can then get a definitive angle, yes? So the snapshot information, never put that in, because when you take derivatives, that would go to 0. If I put a number here instead of x, then dx dt is 0, correct? That part is 0, and that can't be true because the plane's moving, yes? So don't put the snapshot information in until later. What's the relationship between x and theta? Now notice you could do this too if you want to. Couldn't you do this, and this is x, and this is 3? Is that better? What's the relationship between x and theta? What's the geometry in it? What's the trigonometry in this? Sure, cotangent.
Adjacent over opposite. X over 3.
X over 3. Yep, the tangent would be flipped. I like that. Keep the x out of the bottom. That's a good goal. All right, you identify what's changing, you give that a variable. You find a relationship between the variables. I want this to make nothing but sense. Because then they're going to give me information about the rates of change, so then I just take a derivative and I have a relationship between the rates of change. And then I can just shove in what they tell me and crank out what they ask me, yes? So if I get how theta and x are related, I take a derivative, now I know how d theta dt and dx dt are related. And that's why it becomes stupid algebra, because now it's just plugging values in, yeah? So calculus is in the middle of this problem, which is neat. Normally it's at the beginning and the rest of it's algebra, right? So pretty cool, semi-decent with what we've done so far.
Wait, so we use cotangent because
Do it again, sorry.
So I should figure out how we're using cotangent for this.
Because that's the first thing somebody told me.
Oh.
Why wouldn't I use sine, for example?
Yeah, so
Yeah, why wouldn't I use sine?
The hypotenuse.
Do I know what this is?
You can.
Even more importantly, do I care what this is?
oh, no.
No! This is 3. I want to use it because I know that's 3. I want to use that. This is something I have information for, so I want to use that. So I'm constrained. What trig function is going to use? Tangent or cotangent? Why did she choose cotangent? That allows my variable to be on the top. Yes? You guys see that? Smart. You could have used tangent, but then you would have had 3 over x, and that would have made derivatives a little bit freakier. You agree?
Yeah, that makes sense.
Okay. what do you think? What do I do now? I don't know. What do I do now? What do I do? Huh? Yeah, just take a derivative. So, the minute you've got a relationship directly between the variables, they gave me information about the rates, and in fact, they have a question about one of the. Okay, I'm going to take the derivative, because then I'll have this shit show up. And if I see him, I'm going to plug 300 in. And if I see him, I'm going to try to solve for him. Yes? So what happens? What's the derivative? Now you got to be really careful. What am I taking the derivative with respect to? Time. Isn't theta you can do it, Jeff. Isn't theta a function of time? Yes. So real quick. I know I'm the one moving, but just go with me. Is there an angle of elevation if I look up and see the ceiling? Or, this little piece, you with me? As I move, is my angle changing over time? Yes. Okay. I like it. Glad I wasn't recording that because somebody could clip it and make horrible things, but you know what I meant. It was the angle to the top. Okay. So, what is the derivative of this? Understanding this is a function of time. What's the derivative of cotangent of stuff? Negative cosecant squared stuff times derivative of stuff. Now, real quick, this is 1/3 x. Yes, people always freak out about this, but this is 1/3 x. Is that cool? What's the derivative of 1/3 x? 1/3 dx dt. What did they tell them? What can I plug in? What do I know the value of that's in here? Dx dt. What do they ask me for? D theta dt. What else is in here? Damn it. Cosecant theta, right? Cosecant squared. Are you guys understand? Okay. Let me stop from that. So when you have a situation where you're like, oh shit, now this guy comes into play. Don't I have to know the angle at a time when this stuff is true? That's what this means. What am I going to plug in here? 300 miles an hour. And I'm going to try to solve for this at a time when 10 minutes have passed, yes? So I need to know what the angle is when 10 minutes have gone by. I need to know what that angle is. And to be honest, I don't need to know what the angle is. I need to know what cosecant of the angle is. So watch. How fast is that plane moving? All right, so I'm going to use the snapshot. I don't use the snapshot information until I've done the derivative. So after 10 minutes, what is this? So real quick, 300 miles an hour. 10 minutes is how much of an hour? How many minutes in an hour? So 10 minutes is how much of an hour? 1/6. So how far is the plane going? Yeah, 300 times 1/6, right? Dirt, D equals RT, A equals rate times time. So it's gone 50 miles. So at the snapshot, what's the value of x? 50. Do I need the value of x? No. I need the value of cosecant theta. But x is 50, yes? At the snapshot. How do I get cosecant? What am I missing? How do I get cosecant? What is cosecant? 1 over sine. I really want you guys to see. I don't need to know theta. I need to know cosecant squared. If I know cosecant squared is 10, I could put a 10 here. Do y'all agree? So let me focus. I need to know cosecant theta. Look what I know. I know a triangle. There's theta. That's 3. That's 50. What am I missing? Yes. Cosecant is 1 over sine. What does sine need? Y over hypotenuse. I said that very distinctly. How do I get the hypotenuse? Square root of 3 squared plus 50 squared? No. What you're doing right now, you should be saying, would I be able to do that on my own? I'm trying to show you, I hadn't done this problem in a while. So as I'm doing, I'm literally doing the steps, and I'm letting the problem tell me, oh, this is the only thing I don't know. Let me focus all of my attention on it. How do I get that? I've got a triangle. Holy shit, I can get the cosecant. I'm just missing the stupid hypotenuse. What's the hypotenuse? 50 squared is? 5 squared is? 25. 10 squared is 100. So that's 2,500 plus 3 squared. 2,509. So what is the cosecant of this angle? What's the cosecant of this angle?
3 over square root of 25.
No, that's the sine.
Backwards.
Yes. This is negative square root of 2,509 over 3 squared. What's d theta dt? We don't know. What's dx dt? What's dx dt? 300. And now you can solve for d theta dt. The great thing about this is, squaring that's nice. Well, you can do it in your calculator too, but it doesn't matter. By the way, if I let the plane fly more, will the angle get bigger or smaller? If I let the plane fly more, does the angle get bigger or smaller? Smaller. So this should be negative. You can see it's going to come out negative. That makes sense, because over time it's getting smaller. You guys understand now it's just a bunch of calculator bullshit? I almost don't care. So let's see, 100, so it'll be 900 divided by 2,509, which would be, I don't know, it's roughly 0.36, I think. Very roughly 0.36. I don't know if you guys can help me. So it's going to be 100 divided by this, which I can just reciprocate, negative. Square this, I get 2,519 over 9. Multiply both sides by the reciprocal. 1/3 of 300 is 100. And that is roughly 0.36. I would say 0.3589. Just to make up. What is it? Sorry. Negative, sorry. Yes?
Negative 0.3587.
Shit. I'm sorry. What's the units on that?
Degrees.
No, never. Never. What's the correct units for angles? Radians per, what was the time established to be? Not minutes, it was established to be hours. So this is radians per hour. And I love that problem. Of course I do. This is one of the more involved problems, by the way. Don't freak out. This is not like a easy problem. I'd say it's like a medium to hard problem, this one. This one is more straightforward problem, yes? I already gave you the function. If I give you the formula, like, okay, that's much better. Here we had to come up with our own formula, didn't we? Okay, so let's do this. I already promised I was going to chat early. We'll finish this thing first thing next time, and then the rest of next time will be devoted to review. I'll have the quizzes graded.